All right, hello, this is Mr. Wallace again with another Algebra 1 review. This is Lesson 3 Practice, numbers 5 through 7 on page 10. So I did start this equation already. It's very similar to the ones that we were doing before. We're deciding which kind of equation we're dealing with, we're writing the equation, and then answering some of the prompts. All right, here we go. For lunch, Dr. Stranges had a soda that contained 120 milligrams of caffeine. Each hour, the caffeine in his system decreases by 12%. So because we have a percentage, it is a percent exponential equation. So writing the equation, it's y equals 120. 120 is our initial. And then 0.88, how we got 0.88, it's our 1 minus our percentage. So 12% as a decimal is 0.12. So it's 1 minus 0.12. And we can plug that into a calculator or do a little mental math. 1 minus 0.12 is 0.88. So that happens to be my growth rate. And then don't forget your little exponent. I'm sorry. All right, here we go. After 4 hours, how much caffeine is in his system? So we can do this on Desmos. You can use a graphing calculator. I'm using a little tiny calculator here. Using our equation, we're going to use 4 as my exponent. So it's going to be 120.88, and then 4 is my exponent because that's my input. That's my x value. So after 4 hours, we're going to see how much is in a system. So 0.88, I'm going to use my little exponent button of 4, equals, big long decimal number, but then order of operations, we have to multiply it by 120. So times 120. He has, Dr. Stranges, 71.96 milligrams of caffeine in his system after 4 hours. Right? Now, for sake of time, using the table on Desmos, and all of our teachers have taught you how to do the table on Desmos, it's basically just keep on filling in the x values until finally you get a y value that's, where 10 is between. So if we were to plug in 19 into our exponent and then 20 into our exponent, well, we would see where finally in a system there's only 10 milligrams of caffeine left. The long way you can do guess and check, but Desmos is much better to do this using the table feature. So between 19 and 20 hours is when it hits 10 milligrams in his system. All right, number 6. A population of moles in your yard doubles each month. That's not good. It started with 4 moles, and it doubles each month. This is a basic exponential equation because we have this word right here, doubles. All right, so let's write our equation. We have y equals, well, in exponential, we always start with our beginning number, which is 4. And then we put in parentheses our growth rate. Here it's just 2 because it's doubles. We're not dealing with any percentages or anything. And then don't forget your exponent for your little x. So here, how many moles do we have in 7 months? Well, we have our equation, and then we just put 7 into the x, into the exponent there, to see how many moles we're going to have after 7 months. So we have 2 raised to the 7th power. There we go, 2 raised to the 7th power, so that's 2 times 2 times 2 times 2 times 2 times 2 times 2, 128. But don't forget you have to multiply that by the 4 then, order of operations. Very bad news. After 7 months, you have 512 moles. That's not going to be good. You might want to call an exterminator. All right, last one for this video. Number 7, for your birthday, you received a $40 Panera gift card. Yum. You plan to spend it on just Cinnamon Crunch bagels. A Cinnamon Crunch bagel costs $1.69. So this is a constant decrease. There's no percentage, there's no doubling, tripling, there's not exponential. Because this is a constant decrease, a constant subtraction of 169 each time, we have a linear function. Right? Let's write our equation here. So y equals, since we're going down from a gift card, right? The gift card is, each time we use it, it's going down. That means our slope is going to be negative $1.69. Don't forget your x, because negative 169 is our slope. Now, don't forget our y-intercept, which is how much we started with, which is 40. All right? So, negative 169x plus 40. Here you can use Desmos or just guess and check to see how many bagels you can buy. And when I say guess and check, here's what I mean. Once again, in Desmos, you can use that table feature really easily that we teachers have taught you guys. So if I wanted to guess and check, so 169, make it negative because it's a negative slope. All right, 1.69. Let's see, I don't know, if you want to buy 20 bagels. So times 20 is negative 33.8. So I think we can buy some more because $40 is more than 33.8. And so let's see, negative, so 1.69 negative times, let's see, how about 26 bagels? Oh, that's too much, right? We went over the 40. So maybe 24 bagels, 1.69 negative. Can we buy 24 bagels? No, we still can't buy enough. And now that I know that 56 cents will cover in that $1.69, we can buy 23 bagels. So one less than the 24. So that's a guess and check method. Desmos is way easier. Just for sake of time, I'll show you that. All right, thank you so much. I appreciate it.